So for the final part of our work here today with Chapter 3, Section 1, we're going to be finding exact solutions of each equation. I strongly recommend having a unit circle out for this part of the worksheet here. So let's get started. So the first thing I'm going to do is get the cosine, the inverse of the cosine, all by itself. And to do that, I'm going to divide both sides by 2. What this is going to give me is the inverse cosine of x is equal to pi over 2. Now at this stage, with the inverse cosine all by itself, what I'm going to do is now flip for the inverse. So I know that the equivalent equation to this would be changing the position of my y and x. So this is going to be the cosine of pi over 2 is equal to x. What this allows me to do is look up on my unit circle where cosine of pi over 2 is. And the cosine of pi over 2 is 0. So the answer to this problem is 0 is equal to x. In this problem, we're going to follow the same things. We're going to try to get the inverse sine all by itself, but things are going to be a little trickier with a 3 there. So we're going to divide both sides by -6. And so what we have here is the inverse sine of 3x is equal to negative pi over 6. Again, knowing that this inverse sine of x is equal to y, we can flip-flop the xy to get an equivalent equation that is the inverse of itself there. So this is sine of negative pi over 6 is equal to 3x. Now a couple things I want to do here in the next step is, because of our even-odd rules, we can pull the negative out in front of sine. So pull the negative out in front of sine of pi over 6 is equal to 3x. And then go and look on the unit circle at pi, or sine of pi over 6. The sine of pi over 6 is going to be 1/2. But the negative in front of sine is going to be bringing it down there, so there's 1/2 is equal to 3x. All I have to do now is get x by itself, so we divide both sides by 3, which is the same thing as multiplying by 1/3. So 1/3 times negative 1/2 is negative 1/6. And that's equal to x. So there's my answer for that. Okay, 2 more problems to go, and we'll be done with this quick video here for the 3rd page of this worksheet. So here we're going to divide both sides by -4. So the inverse tangent of x is going to be equal to negative pi over 4. And since we know that we can flip-flop these two to get back to our tangent function, so this is going to be on the inside, negative pi over 4 is equal to x. We can then use our even-odd functions to pull the negative out in front. So this is negative tangent of pi over 4 is equal to x. Tangent at pi over 4 is 1, and because of the negative in front of tangent, it's going to be a -1. All right, the final problem looks a little bit more menacing than it actually is. Consider this like a term. And I'm going to subtract the 2 inverse sine of x from both sides. Now what this does, this simplifies to 0, and what I have here is 3 inverse sine of x minus 2 pi is equal to negative 3 pi. Now I'm going to move the 2 pi to the other side by adding 2 pi. And now what I have, these simplify to 0. This is 3 sine inverse sine of x is equal to negative pi. Now what I'm going to do is divide both sides by 3. I'm going to rewrite this problem over here so I can see it a little bit better. It won't be at the bottom of this YouTube video here. So this is going to be sine inverse sine of x is equal to negative x over 3. I'm going to switch these two. If the inverse sine of x is equal to y, we can flip-flop the x and y to get back to the non-inverse, and this is going to be negative x over 3 is equal to, that should be a pi. Wow, how did I turn that into an x? That's just crazy. Sorry about that. So in this case, this is the sine of negative pi over 3 is equal to our x. We're going to pull the negative out in front because of the even-odd properties. So this is the sine of pi over 3 is equal to x. And what we're going to do here is we're going to then look up where we're at pi over 3, what is sine? and that's going to be square root of 3 over 2. The negative's out in front, and that is equal to x. So apart from me just changing pi into x for some strange reason, it's a pretty straightforward problem using your algebra skills from Math 121. All right, well, thank you for watching.